Yo, welcome back. DevGod here, and back with another YouTube video. Today we're going to be solving the Leetcode problem, longest palindrome by concatenating two-letter words together. In this Leetcode problem, we are basically given an array called words that contains only two-letter words. Our goal for this problem is we want to greedily assemble all of these words together to form the longest possible palindrome that we can construct using the given words array. And of course, the palindrome string is basically any string that is able to be read forwards and backwards the same way, no matter if you're reading it left to right or right to left. Of course, a famous example of a palindrome string would be something like taco cat or race car, where basically if you read it left to right, it's going to be the same way as if you read it right to left. For example, a given words array could look similar to this, where we're given two-letter words, and each word could be different letters that are next to each other, or they could also just be the same exact letter like ZZ. So for this example, one thing we could say is that AB and BA should be in the same group since they have the same letters for their word. That goes the same as the words BC and CB. They should belong to their own group as well. And lastly, we can kind of see that the word ZZ, since it's only two-letter Z's, is in its own group. And since we can see that if we take a word plus its reversed pair, we could form a palindrome. So what I mean by that is if we take the AB plus its pair as BA, we know that that forms a palindrome because it can be read the same forwards and backwards. So since A and B plus B and A can be joined together, we can go ahead and add 4. The reason we add 4 is simply because there's 4 characters. This is also similar for the blue group BC and CB, because that also forms a palindrome pair being the original word and also the reversed version of the word. We can form another palindrome and add 4 to our total expected answer. Lastly, because we know that ZZ is by itself, it could be a middle point, so we can go ahead and add 2. So for example, this shows that without having to actually assemble the stream, if we take the past results and check to see if we have the reversed version of the past results inside of our words array, we can greedily add 4 to our current answer. And then for our palindrome, if we have a pair that has the same exact letters like ZZ, we can also say that that is a middle point of the palindrome, and we can add 2 to our expected answer, with that being the middle point. And that's the other piece of the problem, is that only words that have the same letter can be used as a middle point for our constructed palindrome. So for example, I'm given these 3 words AA, BB, CC, only even though they each have the same amount of letters, they have the same letters in the word, only one of them can actually be used as the middle point of the palindrome. So this is how I solve the problem. So I basically start by initializing a map in JavaScript. So this is for key value pair storing, basically a hash map. And I also initialize a score variable set to 0. I'm just going to use this to keep track of the total number of characters that I have in my given string. Take note though how I'm being optimal and I'm only keeping track of the string length and I'm not actually assembling any strings in memory. Next, I use a for loop to iterate through every single word inside of the given words array. And at the beginning of each for loop iteration, I create a variable called swap word that basically just gets the reversed word of the current word that I'm evaluating. So for example, if I'm currently evaluating AB, that is going to swap to the word BA, and I'm going to store that into my swap word variable. So basically my hash map called myMap is keeping track of the frequency of my reversed words, and if I don't find a match between the current word I'm evaluating and the reversed word, I'm going to go ahead and add 1 to the key that has the reversed word. Otherwise, if I do find a match between a previous reversed word and the current word I'm evaluating, I'm going to add 4 to the score, and I'm also going to decrease that word from the myMap hash map. This is basically similar to the example that I drew in XCaliDraw, where if I have an A and a B previously, and then I come across a B and an A, I know that I have basically found a pair using a previous result in my hash map. And since I have found a valid pair, a valid reverse pair, that can be used to add characters to my palindrome, I can greedily say that my length has increased by 4, and then I simply make sure that my map's frequency stays up to date as it should be. Lastly, before I return my score variable as the answer, I use a pretty messy one-liner JavaScript trick to check my map entries for every key that has the same letters. So think about keys like AA, BBCC, those kind of words. And I'm checking to see that if any of those has a value greater than 0 as their value. This is basically a one-liner I use to add 2 characters to my score variable, check if I have a valid middle point in my palindrome. And there we go, we solved the Leetcode problem longest palindrome using a hash map to store previous results, as well as some greedy operations and thinking like greedy developers. Make sure to like and subscribe for more Leetcode videos.